Thank you, Ron. Appreciate it. Hello, everyone. Thanks for joining me in this session today. My topic will be DevSecOps with IoT. Is it a myth? Well, we'll see. So this is Neil Mitra. I'm a worldwide specialist solutions architect on IoT, had been working for AWS close to 4 years now, based out of New York. Super excited to be in front of all of you again. This is my third time at Angel Bits. I think first time was 2017. So really appreciate Ron giving me the opportunity again. So while you were here, I guess you care about, DevOps, security, IoT, cloud, or everything. So you are at the right place at the right time. In this session, we will start with the insecurity of things to help you understand why IoT is complex and why security is so important there. And then I will introduce you to different AWS IoT services in case you are not familiar. And then we'll get into the weeds, focusing on the edge computing specifically. So you will learn how do you develop, operate a new generation of applications at edge securely in an agile fashion without being an embedded developer. And finally, I will show you a quick demo and get you going to your last session of the day. So with that, let's get started. So if you're here, you know the potential of IoT. IoT is being adopted across different verticals: connected home, industrial, agricultural, financial, automotive, and whatnot. And I primarily focus on customers in the automotive and in the connected home space. So according to IDC, worldwide technology spending on Internet of Things will reach around $1.2 trillion in 2022, which means as developers and architects and engineers, you will have a lot more solutions to design, architect, and build. And we can see a lot of them part of our lives today, honestly, like starting from our phone. It's like the first, IoT device that got commercialized. And today we see Alexa, we see drones delivering packages. IoT is essentially everywhere. But being everywhere is also a problem, because that's where your security perimeter gets larger and you need to deal with many threats, such as denial of service, where IoT devices prevent access to legitimate web services, or it could be lateral threat escalation, where hackers can use IoT devices to bypass perimeter security and access critical IoT resources. And there could be many others. And these threats are not going anywhere anytime soon, since IoT solutions are multidimensional, and that's why it's kind of complex as well. So you have to deal with several layers here. Firstly, you have the edge, right? This is where you onboard, operate, and manage your devices. That goes into the field. Then you have the communication layer, which handles the connectivity, the message routing among devices between the device and the cloud. Then you have the ingestion and analytics layer, where you aggregate all these disparate data streams created by your devices to help analyze the data, visualize the data, perform machine learning. Paula, we just talked to you about how you do machine learning. So IoT is kind of the data ingestion for you, so you can do all the analytics and machine learning and BI for different kind of use cases. Then you have the applications layer. This is where you might have user applications, very simple ones. We use our phone to maybe unlock our car, or we use our phones to change the temperature of our thermostat, user applications, or it could be through voice as well. Or there could be management applications, where you give your field technicians a way to manage the devices on the field. For example, you call a home security monitoring company, and they come and they set up everything for you. So there could be all these different kind of applications. And you can imagine with all these layers, it's very difficult to identify issues and engage to mitigate them quickly. So the obvious question is, how does AWS help customers there? Okay, let's see. So what we try to do, we have simplified this multidimensional ecosystem into a three-tier architecture. And learning from the experience of millions of our customers like you, we have built different services for different use cases across this layer. So for example, on the device layer, the bottom layer on the screen, you can see something like a device SDK, where you can use SDK in different programming languages like Java, Node.js, Python, Golang, you name it. And you can use this SDK for different IP connected devices. Then we have something called Amazon FreeRTOS, which is actually now just FreeRTOS, is open source. It's an operating system for microcontrollers. So think of sensors and fitness trackers and any devices as such which has very low resource, such as maybe 64 KB of RAM. Yeah, KB still exists today. Or Greengrass. Greengrass is where you bring a lot of edge computing capabilities as a gateway or powerful appliance and connect all your data to different services in the cloud. And in this session today, I'm primarily going to focus on the edge, because when it gets to the cloud, things get much easier. But when it's not in your physical perimeter, when the devices exist on the field, that's where the fun begins. So the middle layer is a control layer. This is where we have built different control services, like the IoT Core, which is a managed platform. It's a gateway which can support billions of devices and trillions of messages. And then you can take all these messages and send it to your data lake using different kind of rules. And on top of the data lake, again, you can do analytics, you can do machine learning, you can do BI and whatnot. So now you have billions of devices. How do you manage them? That's where we build IoT device management, which helps you organize and manage your devices so that you can do firmware updates. You can do different kind of OT upgrades, maybe a zero-day security patch. And that brings us to Device Defender. You have billions of devices and they're prone to different kind of attacks and vulnerabilities. How do you continuously audit them? How do you continuously ensure that the IoT configurations on those devices are not deviating from the best practices? And that's where IoT Device Defender can help you. And finally, Things Graph, which helps you rapidly build IoT applications. So our customers told us that this is great, but how do I get started quickly? Do you have anything? So that's why with Things Graph, you can connect different sensors and actuators to different web services, such as Amazon Recognition that you just heard about in the previous session. And it can speak different protocols. You just do drag and drop and boom, you are good to go. And finally, the top layer is the data services layer. This is where we have built certain services focused on IoT. So IoT analytics, it's a service that collects, pre-processes data, time series data essentially. And then once you have ingested all those data into a data store, IoT analytics can perform tasks for you. It can help you run ANSI SQL-like SQL queries. You can do, again, machine learning on top of the data because it's integrated with SageMaker. You can do visualization because it's integrated with QuickSight. And then comes IoT events. So it's easy when you have a couple of sensors maybe to identify if there's a failure or if you need to respond to a certain event. But what if you have billions of devices and you have billions of sensors? You need to have an event orchestration engine which helps you to identify the states of different machines and then take actions in near real time if needed. So that's what IoT events helps you. And finally, IoT Sitewise is our service for industrial customers. So if you're dealing with lots of OPC data, you have a lot of MES systems, SCADA, PLCs, that's why Sitewise is a good fit. So you can imagine that we are trying continuously working backwards from your feedback to remove the complexity of implementing IoT into the business. And millions of customers we have, starting from Vizio and Philips and iRobot and GE. This is just a snapshot of some of our customers. They have been using IoT Core every day. So even you are probably using many of the products today without knowing you are using some of these AWS services. Okay, with that background, let's get into the weeds. Firstly, I hear this question often: what is edge computing? Is this something new? We thought cloud computing solves all our problems. Well, the first generation of enterprise applications, if you think about it, were built with focus on people, like CRM or ERP applications. And we can refer to them now as IOP or Internet of People applications. But today we are talking about building solutions for things. Thus, we need a decentralized system closer to people. Again, think of Alexa, think of our Apple Watch, which serve our needs, which serve your needs, right? And thus, this concept is not new, but we see a lot more implementations of this today. So how does it work? In simple terms, you have devices again, like your thermostat, light bulbs, watch, whatever it is, that exists just in a local network. It uses Wi-Fi, Bluetooth, maybe Zigbee, Z-Wave, and is often managed through a local gateway because they still need to work. You still need to lock your doors even if you do not have internet connectivity. So the local gateway will do command control, message routing, data aggregation, and when it needed, it will also send the status to the cloud for you to have a near real-time visualization of what is happening with my devices. So you can see there's a lot happening on the edge, but then that is an extension of the different cloud services that we build. So how do you develop for the edge? That's the interesting part, right? So there could be different kind of hardware. There could be microcontrollers, which is running like ESP32, if you have heard of it from Espressif, and there are many other microcontroller boards, or it could be a microprocessor from NVIDIA and others. Or Raspberry Pi maybe, or Arduino that you have heard, which are great for development kit, but not for production. So traditionally, you have to be an embedded developer using low-level languages like C, C++, and others. Right? And our customers asked us how they can practice DevSecOps patterns with edge applications. On cloud, common for customers to do thousands of deployments every week. Can we do something similar with edge applications as well to continuously innovate and improve the customer experience? And that's where Greengrass helps, which is a comprehensive edge solution that brings a local messaging broker, local compute, data caching, local status sync, the machine learning, OTA to the edge devices. So it can act as a gateway appliance. It's a software. So you put that in a device and the device can act as a gateway appliance, or it can act as a very powerful device. But the cool thing is it can be operational in a completely offline mode. So no internet connectivity, that's fine. It will still continue to operate. So again, think of a connected car. If it is outside of a network zone, should it stop its functionalities like your infotainment system or the music or anything else? No, right? So that's what Greengrass tries to bring. It brings a lot of capabilities from the cloud to the edge, but at the same time, it's operational even when internet connectivity is not there. So it's a software that can run on any hardware, which is x86 or ARM-based architecture. It needs at least one core of CPU and 128 MB of RAM. You can run this on different flavors of Linux, as you can see on the screen, or as a Docker container on non-Linux platforms. And on top of Greengrass, you can deploy your code, and that could be using Lambda functions or Docker. In case you are not familiar, Lambda is our serverless solution. That means you just write your code, you package it up, you deploy it to the cloud, and we take care of running that. So now you can run Lambda onto the edge as well. If you're developing in languages that is not supported by Lambda, or you might have existing investment, what do? Use containers. And then you can deploy all this code over the air to the Greengrass enabled device, and it will just run there. So what did you learn? You don't need to be embedded developer anymore to build edge applications. If you forget everything about this session, just remember Greengrass and how you can run code not being an embedded developer onto the edge. You can use your existing skill of Java, Python, Node.js, etc. So what are the different components of Greengrass? It all starts with a Greengrass group. It's a container of all the different applications and resources that will be pushed to the edge. So on the right side of the screen, what you see, this eventually runs on the edge device or the hardware device that sits with your end customers. The heart of Greengrass is essentially Greengrass core that you see here. It's essentially the daemon that is doing all the orchestration. It's like the brain of Greengrass. Then you have Lambda functions, you have containers where you bring your own application code. You have subscription, like how do all these messages gets routed from the Lambda to the cloud? How do I do that? That's where subscription comes into the play. You have something called connectors, which helps you to connect to different AWS or third-party services without writing a line of code. And we'll talk more about that. And also you have resources, like I want to deploy my machine learning model, which is in the cloud, because I want the inferencing to happen on the edge. My car is going to crash, right? I need my machine learning model to infer that and stop my car. So that's where machine learning on the edge is becoming so common in different solutions and hardwares that you see today. Thus, machine learning is not only limited into the cloud, it's in the edge, very much in the edge, and solves a lot of real life problems. So how do all these components communicate again in conjunction? This is how it does. Devices can communicate to each other directly. For example, if you are running Greengrass as a gateway, you can have thousands of devices like the sensors and actuators behind that gateway working in completely offline mode. And then since you are sending all these messages from different devices or to a Lambda function, you need to process those messages locally maybe. Because remember this, if you are sending all the data, all bits and bytes to the cloud, you are paying for that, right? What if you can figure out what messages can be processed locally versus what can be sent to the cloud? That's how you can also optimize your bandwidth usage, which is very important for resource-constrained devices. This is how container works. So if you're not using Lambda, you're using container, you can just port that on top of GG. You will deploy GG's Greengrass, and you can deploy that over the air to the edge. Now your code can be in your private registry or in the Docker Hub, or it could be in the Elastic Container Registry. It doesn't matter. It could be anywhere. And you can use your CI/CD pipeline to build the code the way you do it today. The only step you need to do to integrate with Greengrass is associate these Docker images to a Greengrass group, and then finally click a button to deploy it over the air. And that's pretty much it. Of course, you can automate this whole thing. We'll talk about that. And you can also use CLIs. You can use consoles, whatever you're more comfortable with. But in real world, you will probably need more automations. But in prototype, it's fine, whatever you do. And edge is growing every day. It's actually growing by leaps and bounds. So you can get different compatible hardware solutions, community support for production grade deployments as well. So it's beyond just, I have my Raspberry Pi or I have my ESP32 working fine. That's fine for development. But for production, you need production grade hardware and solutions. That's where we have a huge partner community to help you. Okay, that's great. So you learned about how you can develop for the edge using Lambdas and containers and then deploy over the air. Now let's talk about security. Let's switch gears. So by now you might have learned about shared responsibility model. So in cloud, when we talk about AWS shared responsibility model, we talk about security of the cloud, where AWS is responsible for protecting the infrastructure that runs all of the services offered in the cloud. So the infrastructure composed of the hardware, the software, the networking, and the data centers that run these services. And we at AWS are responsible for managing the hypervisor down to the data center. Right? What is customer responsibility? Your responsibility is security in the cloud. That means you are responsible for the data that you bring in. You are responsible for the applications that you design. We give you all the tools. We give you all the best practices. But end of the day, it's your application, and you need to determine what level of security is needed. So you need to enable those options as well. How does it extend to IoT? As a customer with IoT devices, these devices are your responsibility as well now because they're not in an AWS data center. We manage hypervisor down to the data center on the cloud side, but on the edge side, you are managing your hardware. Again, we work with you along the path as AWS and partners. We provide you software, different services, different tools, different security mechanisms. But at the end of the day, you have to ensure that you are aligning to that. So with that, let's talk about security from a Greengrass standpoint. Greengrass devices authenticate to the gateway of the cloud using X509 certificates. So you have a private public key pair, and you need to ensure that private keys are completely secure. So that's where you use something called a hardware security element, which is offered by different hardware vendors. You need to ensure that your keys are not left unprotected on the file system. It has to be ephemeral in a secure element and can only be accessed using a PKCS interface. Thus, your devices cannot be compromised easily. So that's on the cloud side. That's on the edge side. And all these devices, whenever they need to communicate to the cloud, they are also going to use TLS 1.2. That means your data is protected in transit. What happens to the cloud? Every Greengrass group is associated with a service role. That means it's an IAM role. In case you're not familiar, IAM is Identity and Access Management, which essentially manages all kind of authorizations on the cloud side. So same rules apply for IoT as well. So with Greengrass service role, you can associate least privileged access to all these different components that you need in a Greengrass device. If you think that you need Lambda, ensure Lambda has the least privileged access. If you need container, do the same. If you need some other features, you have to always ensure that the Greengrass service role that you configure during creation of the group has least privileged access. That way, from the edge to the cloud, you are essentially protecting your secrets and aligning to the security best practices. Now, there is another important thing, IoT Greengrass Secrets Manager. This helps you to deploy secrets to your edge devices. So we talked about having all these applications, whether it's Lambda, whether it's container, onto the edge. But with all the applications, you might have different kind of credentials, different kind of keys, different kind of endpoints, different kind of configurations. How do you ensure that those are protected as well? So that's where you use Secrets Manager, which is available in the cloud as well, and associate all your secrets with a Greengrass group and deploy it over the air. And that's it. Your life is much easier. And finally, you can also create security profiles with Greengrass-enabled devices and any IoT devices as such, using IoT Device Defender, which is our security service for IoT. So security profile can include device-side and cloud-side metrics. You can collect device-side metrics like packet size or bytes in and out. Within the cloud, you can enable monitoring around auth failures or increase message sizes. That gives you the visibility to understand, oh, if my payload size has increased substantially, maybe my device is being used for a DDoS attack and whatnot. So what you can do, you can build an automated mitigation pipeline using these services as well. Because think of it, like if I have a smart switch in my home, that can stay there for 20 years. And I need to ensure that only during the onboarding it's secure, and after that I don't care. That approach won't work. You have to ensure that the experience of the customer stays throughout the life cycle of the device. That's where you need to ensure that you use a security service to continuously audit your devices from time to time. Now, if you had been to our reInvent, which is our yearly conference, you might have taken one of our shuttles that takes you from one resort to the other, and you can see the waiting times of different bus lines. How do you do that? What do? We capture all the images and videos from different cameras at all these different locations, aggregate that data locally onto this Intel logic box that you see, which is running the Greengrass software. And then all this data is being locally persisted and showed on a dashboard that you can see in the bus lines, but it is also sent out to the cloud and is published to an API gateway, and that's where you see on the mobile applications as well. But note, what if one of these devices, which is on the field, gets compromised? That's why AWS Protective Services team, they're using hardware security element and Intel TPMs, Trusted Platform Modules, and many other security practices to avoid the device getting compromised during the show. Now, you learn so far about developing on the edge, right? Without being an embedded developer, you learn how to do the security, right? Like end-to-end security. But you have to think about operating as well, because everything fails all the time. It's important for you to monitor and operate your workload through an automated pipeline. That's fine, but you still have to think about that. So how do you monitor? AWS IoT gives you different kind of event messages. For example, events are generated by the registry, device registry, when devices are added, updated, deleted, and whatnot. On the data plane, you might need to collect a lot of log data, a lot of metrics. That's where CloudWatch helps you. On the control plane, you have all the APIs. And how do you capture, like, some delete API has not been invoked and I do not have the traceability who did it? That's where CloudTrail helps you as well. And we do a lot of operational dashboards as well out of the box that you can use, but you can create your customized versions as well. And now you are monitoring all these devices. You know that, okay, I probably need to update all my devices running firmware version 1. How do you do that? Greengrass offers an inbuilt capability of OTA updates, so you can push updates over the air as many times as you want, security updates, bug fixes, new features, and whatnot. So you can continuously improve the experience of your customers, keeping the environment secure. Finally, Greengrass connectors, which is great because connector saves you some coding effort. If you're an enterprise, you might be using something like Twilio or Splunk. And what we did, we have built those connectors for you. So you do not have to write the code. You just have to ensure that you are connecting to ServiceNow or Splunk or Twilio or AWS services like Device Defender that we talked about or CloudWatch that we talked about. So without writing code, just enable the connector and we do everything for you. Okay. So with that said, in the interest of time, I'm moving really faster, but you learned about developing for the edge. You learned about some of the security postures for the edge, and you learned how to operate. But guess what? Seeing is believing, right? How does all these things together? So this is a reference edge to cloud architecture, and you can note down the GitHub link, and these PDFs will also be shared with you, so you can go and get your hands dirty there. But real quick, you will have a lot of sensors, right? It could be bulbs, it could be thermostats, it could be other kind of devices which will continuously generate data. And then you will have a Greengrass, which probably is acting as a gateway to collect all this data. So you see a Lambda function here, which is for this workshop, generating the sensor data from all these devices, which sends it to another Lambda function called stream producer, which is taking all this data and essentially sending the data to something we call stream manager. So with stream manager, what happens, you can process a lot of data locally without sending it to the cloud. And then you can also aggregate the data. So you can send the data serially. Whatever data I get, I do some kind of filtering and I send it to the cloud. It's my time series data. Everything is stored in IoT analytics, and then I visualize it through QuickSight. Or you can say, you know what, I also want to filter out some data for a different use case, and I want to aggregate all this data and then finally send it to Kinesis data streams. I can probably run some kind of analytics on it, and then I can store it in S3, the data. So now, back to story. How do you ensure that this whole thing can be built in an automated fashion and deployed? Of course, in the real world, few things will change, like the manufacturing process of your devices will be there, and they will have a provisioning mechanism. But other than that, after the first time, once your Greengrass devices are enabled and deployed, you can continue to update them over the air, whether it's on the edge or on the cloud. The last piece I didn't mention here, there is a Docker container which is running a Flask application. So think of it, it's a local application. You may not have connectivity to the internet all the time. You can have Docker container as a HMI to visualize what is happening from your devices, which is awesome, right? So with that, I want to quickly show you the whole stack here was created using a CloudFormation template. So this is a template. It creates a Greengrass groups. It creates a Lambda functions. It creates all of the stuff that you actually saw on the screen. And once it is created, I have started the Greengrass in the simulator in the Cloud9 environment. So you can see I am running it in a Docker container. So Greengrass can run natively, or Greengrass can run within a Docker container. So here I'm running Greengrass in a Docker container because I like Docker, but you can choose anything. And then on the IoT console, there is a Greengrass groups, and I have a Greengrass group called Greengrass Stream Manager, which is created through the CloudFormation template. And here you can see all these different features, like, okay, what are my subscriptions? That means routing rules. What is my core, which is, if you remember, the brain behind the Greengrass group. What are the different devices communicating? What are the different Lambda functions that needs to process? So I associate all these resources within this group, and then I go to actions and I will do deploy, and that's it. So every time, this is what you're going to do. If you need to deploy new functionalities, you add to Lambda, you add devices, you add different routing rules, and finally you update over the air using deploy. That's pretty much it. And this can be automated as well using CLI. And finally, in IoT analytics, you see the time series data, and we can run ANSI SQL queries, which is coming from the devices, and see what is happening. So in the interest of time, let me make it real quick. You can get your hands dirty again. This is the workshop URL. So to summarize, what did you learn? DevSecOps can happen for IoT. It's not a myth. So you can build an end-to-end automation pipeline. You can use different tools such as CloudFormation and other code services that we have. You have end-to-end security features, starting from the ARM roles on the cloud, TLS 1.2 for mutual auth and data encryption in transit, and hardware-specific features like integration with secure elements and PKCS, and hundreds of security certifications, more than anyone in the cloud, for you to manage and operate devices. Now, this question comes often. Okay, this is all great. How do I start with IoT? So that's where you can go to this link. We have developed a training library for all our services, including IoT. So last year, we made a lot of this content available for free to you, our customers. So you can get your hands dirty with a lot of other stuff as well. Or we also have a rich device catalog with devices such as Deep Racer and Deep Lens that you can buy from Amazon.com, if you have heard of that name, and you can start playing with it. Or you can buy development and production grade kits such as like the NXP kits or the ESP32 kits. So to get started, if you don't want any of these kits, just buy a Raspberry Pi and get started. We also have a course in edX.org if you're looking for more use case oriented, hands-on use case along with certifications. Go ahead, give that a try. That's also a great course. And finally, we can see around us, the world is changing more than ever. Today, we need to run our businesses and life using technology as an enabler. And I really can't wait to see what innovative applications and IoT applications you guys will build and develop in the future using some of this edge and cloud services. It's just day one, and there is a lot more to come. So with that, thank you for your patience. I know must have been a long day for you guys. Really appreciate all your time. Back to you, Ron.